This lesson is on completing the square. Completing the square is a way of converting from standard form into vertex form. So I'm going to walk through it really quick and then we'll do a bunch of examples. You can obviously come back to this slide at the beginning uh, throughout the examples to kind of see what it looks like in with words and everything else. So if you need to pause and come back to this might not be a bad idea. You start with a quadratic in standard form. The first thing you will always do is you will factor the a value out of the first two terms only. Notice that the c still stays there kind of all by itself. So you do not have to factor a out of the first two terms. If you don't have to factor an a out of the first two terms, you still do everything exactly the same as this. So if there's no a, you don't have to worry about this stuff because a is 1. So you would basically be doing everything without the a, because a is 1, and it would look like this. Okay, so everything would look exactly the same even if there is no a. But you factor a out of the first two terms if you need to. Okay, then put some blank spots in your equation right after the regular x term and right after the c. You'll see how this works when we actually go through it. Then you divide the middle term, this term, by 2. That's going to go in here. So you'll divide that term by 2. That will go inside the parentheses when you're done. And then you're going to take that divided by 2, and you're going to square it and put it in that blank spot. So that's where it would go. Then you have, since we just added something to an equation, we have to subtract that same value from the equation. So we're subtracting it over in the other spot. That's where that happens. Now, one thing you need to notice is that I put a 4a squared here, and I'm putting 4a over here. That's because what did I really add? I added b squared over 4a squared times a. So because I added b squared over 4a squared times a, I really only added b squared over 4a. So that's why I'm subtracting b squared over 4a. And then since the thing in the parentheses is a perfect square, which is the whole point of doing this, we're completing the square. We're trying to turn this into vertex form. You want to write it in vertex form when you're done. That was a pretty quick synopsis with a bunch of letters. So now we're going to get into what it actually looks like in real life. Change the following equations from standard form to vertex form by completing the square. Confirm it by using negative b over 2a. So we should know in the first problem that negative b over 2a is 12 over 2 times 1. So our x value of the vertex should be 6. And when we substitute this back in, we're going to get negative 9. So our vertex is going to be 6, negative 9. And our equation, when we're done, will be y equals, a value is 1. So y equals x minus 6 squared minus 9. We know that that's going to be the answer when we're done. So if we don't get that, we know we messed up. My first step is to factor a out of the first two terms. There is no a here, so I don't have to worry about that. So what I'm going to now do is put blank spots in my equation. So x squared minus 12x plus blank plus 27 minus blank. So I'm going to subtract the same thing that I add. I'm going to take this negative 12. I'm going to divide it by 2. So negative 12 divided by 2 is negative 6. And that's going to go inside the parentheses that we showed earlier. And I'm going to square that. Negative 6 squared is 36. So I'm going to add and subtract the same thing. So I added 36. I'm now going to subtract 36. So what I end up with is x minus 6 squared minus 9. That's exactly what we thought we would get. So that's good. I could rewrite this if I really want as y equals x squared minus 12x plus 36 minus 9, but I don't need to do that because really the whole point of this is to change this into vertex form. And x squared minus 12x plus 36 does factor into x minus 6 times x minus 6. That is the entire point of what we're doing. We're completing a square. So x minus 6 times x minus 6 is a perfect square. It's x minus 6 squared. And that's why we're doing what we're doing. Every single time, you should get a perfect square in these parentheses when you're done. And if you don't, then something went wrong. So now let's go to the second problem. Keep those rules over on the side. X squared plus 6x plus 13. So let's confirm negative 6 over 2 times 1 is negative 3. That's our x value of the vertex. And if we plug this back in, we're going to get 4 for the y value. So y equals x plus 3 squared plus 4 should be what we get when we're all done. So there's no a again. So y equals x squared plus 6x plus blank plus 13 minus blank. So now we just have to fill in the blanks. 6 divided by 2 is 3. So we get y equals x plus 3 squared. So that 3 then gets squared. So 6 divided by 2 is 3. 3 squared is 9. I added 9, so now I have to subtract 9. And 13 minus 9 is 4. So we ended up getting exactly what we were supposed to get. Now let's look at the third problem. The third problem, we actually have an a value, so we have to do something here. Let's confirm what we should get when we're done. Negative b over 2a is negative 8 over 2 times 1/2. So our x value of the vertex is negative 8. And then our y value of the vertex is what happens when we substitute negative 8 in. So when we substitute negative 8 in, we should get negative 9. So we should get negative 8, negative 9 as our vertex value, which means we should get y equals 1/2 x plus 8 squared minus 9. Okay, so let's first, now this is our first time we have to factor the a out of the first two terms. So y equals 1/2 times x squared plus 16x plus blank plus 23 minus blank. So notice what's going on is we have 16 times 1/2 would give us the 8 that we started with. So this 1/2, if we distributed it in, we should end up with exactly what we started with. So I factored the a out of the first two terms, and I put blank spots in my equation. So that's good. Now, let's figure out what to do. So we have 16 divided by 2 is 8. So 8, and then we're going to square that and get 64. Okay, 8 squared is 64. So we just added 64. Oh, wait a minute. We didn't add 64 to the equation. Because remember that we have 64 times 1/2 that got added to the equation. So that means we really added 32 to the equation. That's what we really added. So if we really added 32, that means we need to subtract 32, not 64. We need to subtract 32. This is a major thing. We really have to make sure we add and subtract the same value, not what we think is the same value. Finally, we end up with 23 minus 32, which is minus 9. So notice the thing I just erased is exactly the same as what we had before, or exactly the same as what we just got now, and our vertex is negative 8, negative 9. Again, you can graph all these things on the side, but I'm not going to spend the time graphing them right now because we're trying to focus on completing the square. So let's take a look at these problems. I'm going to do these problems without having our cheat sheet on the side. So if you need those, hopefully write them down. Go back to a previous part where you can see it. First thing I'm going to do is write the same equation with blank spots and factoring that -2 out. So I have x squared minus 4x plus blank. Then I have plus 5 plus blank. Okay, now notice that I just put a plus blank here instead of a minus blank. And the reason why this is a plus is because when we are done, we're actually subtracting something from the equation. So I'm going to have something in this spot where the arrow is, but it's going to be multiplied by -2. So that's an important concept that we have to understand. Add and subtract the same value. And in this case, we're actually subtracting something at the beginning. Okay, so now I'm going to divide this number by 2 and square it. So I have y equals -2 times x minus 2 squared. And then I'll figure out what that number is in the backside of the vertex form later. -2 squared is +4, so I put a +4 in here. I'm always putting a plus in here. That will never change because if I have a perfect square, that's always going to be a plus. But what I have to notice is what I really did was I added -8, or I subtracted 8 into this equation because I'm multiplying by that -2. So since I subtracted 8, I have to add 8, which means that my vertex is actually at 2 comma 13. We should be able to confirm this by doing -b over 2a. So if I do -8 over 2 times -2, I get an x value of 2, which is good. And then when I substitute that in, I get um, 16 as the middle term, -8 is the first term, so that's +8, and then +5 gives me 13. So that confirms exactly what I thought the vertex was. Number 4, we're going to factor out a -1. So this is something that's important for us. We don't want to start with anything that's negative without factoring it out. So we're going to have x squared minus 4x plus blank minus 3 plus blank. Again, I'm putting a plus here because if I have a negative sign on the outside, what's going to end up happening is it's -1 times whatever gets added there. So you have to be careful about that. So I'm going to take this -4. I'm going to do -4 divided by 2, which gives me -2. And then I'm going to square that and get +4. -2 squared is +4. But again, remember that I'm actually subtracting 4, so I want to add 4 here. So -3 plus 4 gives me 1. I'm going to confirm that this should be what we have. Also, quick timeout. Notice that every single time I do this, my A value always ends up the same. So just like we learned earlier, A value in standard form is the same as the A value in vertex form, which is the same as the A value in intercept form. So my A value is always the same in every problem that I've done from start to finish. So if I take a look at this problem here, I'm going to confirm what I've just done. So I have -4 over 2 times -1 gives me an x value of the vertex of 2, which we got here. And then if we substitute 2 into the original equation, we get +1 for the y value of the vertex. Finally, let's talk about a problem that has no c to start. Okay. Really quickly, if I factored this, this is not what we're doing, writing things in factored form, but if I factored this, I would end up with 3x times x minus 2. So I know that I have intercepts, x-intercepts at 0, 2. And also, one other thing that I should be aware of from that is that my x value of the vertex is going to be at 1 because it's directly in the middle of my intercepts. I can confirm that using -b over 2a. So if I take 6 over 2 times 3, I get an x value of the vertex of 1, which is exactly what I thought. So I have that, and I substitute it back into the original equation. I get a vertex at 1, -3. That should be something that I get confirmed when I'm done with this problem. So what I'm going to do is I'm going to rewrite this. by factoring out the 3 to start from the first two terms. So I get x squared minus 6x, or I'm sorry, minus 2x. I factored out a 3, and then I didn't actually factor it out. So plus blank, and then it's plus 0, so I don't even really have to write it. Notice that there would have been a plus 0 here if I wanted to put my c. So plus 0, if you want to keep it, you can. And then I'm going to put minus blank, and the reason I'm putting minus blank again is because I'm going to be adding something to this equation. So I'm going to want to subtract the exact same thing when I'm done. So y equals 3 times x minus 1 squared. That's because negative 2 divided by 2 is negative 1. Then when I square it, I get positive 1. Positive 1 times 3 is 3. So I really added 3 to this equation, which means I want to subtract 3 from the equation when I'm done. So I get 3 times x minus 1 squared minus 3, which is exactly what I should have got because 1 negative 3 was supposed to be my vertex. Last thing I want to talk about. When you complete the square, I basically just copied everything from the front, except I replaced y with 0. So I replaced y with 0. What I'm about to show you is a proof of the quadratic formula. So the entire first part here, all the way down to what you can see at the bottom of the screen, is exactly what we've just done. This is completing the square, except I replaced y with 0. So now what I can do when I replace y with 0 is I can now solve for x. So I'm going to take this stuff and add it or subtract it over to the other side of the equation. So I end up with b squared over 4a minus c. That's just adding or subtracting it to the other side of the equation. Oh boy, where are you going? Then I can take this a and divide both sides by a. Okay, so if I divide both sides by a, that gets rid of the a on the right and puts an a squared on the left in that first term and a divided by a in the second term. Then I can get a common denominator, so I multiply the top and the bottom of this fraction by 4a. That gets me b squared minus 4ac all over 4a squared. Then this step is combining them into a common denominator. If I take the square root of both sides, then I end up with plus or minus the square root of b squared minus 4ac all over 4a squared is equal to x plus 2a. Then, obviously, the square root of 4a squared is equal to 2a. As long as we have that plus or minus in front, it's technically the absolute value of a, but since we're doing both cases, we can just kind of leave it as 2a. And then I can subtract the b over 2a from both sides, and I end up with the quadratic formula. So if you ever wondered where the quadratic formula came from, it actually came from the process of completing the square. And that's part of the reason why it's important to be able to change from standard form into vertex form. But finally, since we actually know how to confirm our answer using negative b over 2a and all that other stuff, you might be wondering why we actually have to know how to complete the square. Well, when we get to our 6th unit or our 7th unit of the year, that's called conics. And in conics, we graph ellipses and parabolas, which we're doing right now, but we can also do some sideways parabolas. We graph circles, and we graph things called hyperbolas as well. So hyperbolas have, it's basically like two sort of parabolas, which aren't quite parabolas, and they open opposite directions. In order to graph many of those things, you have to use completing the square in order to get it into a form that we can graph. There's no trick or shortcut like negative b over 2a in a lot of cases. So you have to know how to complete the square, and that's why it's really important that you do it now. And we're making sure we practice it a lot so then we can do it not only on this test, but when we get into conics later.